Good morning again. So today we are going to see how to project the points and how to draw the front and top views of the point in the paper. In this class only we are going to connect our virtual world and our real world. The virtual world is nothing but the horizontal plane, vertical plane, first quadrant, second quadrant, third quadrant. This is nothing but the virtual world. And the real world is nothing but your paper, drafter, pencil and your drawing board. This is nothing but the real world. So here we are we are going to take a very important step in today's class. Now only we are going to connect the reality and virtual. How to obtain the result from the virtual world and how to make it in our real world. So today's class plays a major role and please keep listening. Our horizontal plane and vertical plane. So this is nothing but your vertical plane, that's nothing but your horizontal plane. This space is first quadrant, okay, that space termed as second quadrant, and here we are having third quadrant, and there we are having the fourth quadrant, okay. And in the case of orthographic projection, I already in the last class mentioned you that we are going to work with various kind of objects classified based on their dimension. So starting from the points, dimensionless entity, and one dimensional entity lines, two dimensional entity planes, and three dimensional entity solids. So in this way we are going to practice, and first we are going to start with the projection of points. This is what the topic we are discussing today. Projections of points. Already I have told you, projecting is nothing but an activity of developing the front and top views of the object. Projecting is an activity of developing the front and top views of the object. And our end aim is to draw the front and top views in the paper. For that, first step you have to project the object, then you have to obtain the front and top views of the object. After that you have to draw the particular front and top views in the paper. So three stages of operations we have to do. Out of these three stages, the first two stages have to be done with your imagination, that is in the virtual world, and the last step only we are going to do in the paper. Fine. This is our environment. Let me to start with a question. Okay, with a question. Now I am going to draw the projections of a point. In order to draw the projections of a point, the input data is the location of the point with respect to the horizontal plane and vertical plane. Then only we can draw the point, draw the front and top views of the point. Let me to write the question here. A simple question. A point. The name of the point may be A. The name of the point may be A. Is 25 mm above horizontal plane and 35 mm in front of vertical plane. You have to draw its projections. This is what the question. A very simple question. A point is there. The point name is A. The point name is A. And that point is located 25 mm above the horizontal plane and 35 mm in front of the vertical plane. See, just I have told you, the location of the point is given with respect to the horizontal plane and the vertical plane. Two data is very important if you want to say the detail of a point with respect to a principal plane. The first data is that whether the point is above or below HP or in front of behind of HP, first data. Then if it is above, how much above? If it is below, how much below? If it is in front, how much in front? Okay, so in that way I just given a problem. So by using this words, are you able to predict in which quadrant the point is now existing. It's just like a puzzle game. Okay, by reading the data, you are going to predict where it is actually. So the point A is 25 mm above HP and 35 mm in front of VP. So in which quadrant the point may be there? Out of first, second, third, fourth. Yes? No issue, you can switch on the mic and you can respond. It's our class.
First quadrant, sir.
Very good. The point is in now first quadrant based on the given data. Okay, based on the given data, nothing beyond that. The point is located above HP. So if it is above HP, there is no possibility for third quadrant and fourth quadrant. In that way, we can move step by step by neglecting the wrong answers. If it is say above HP, automatically the quadrant 3 and quadrant 4 are disqualified. The only possibility is for first quadrant and second quadrant. And then continue reading. 35 mm in front of VP. If it is in front of VP, there is no possibility for the second quadrant. So the last only possibility is first quadrant. In that way, step by step, you have to neglect the reject the wrong answers, and you have to move closer to the right answer. For that, a deep reading and cautious reading on the question is essential in case of engineering graphics. You have to read the question perfectly. You should not just go like that by just reading the English. You have to read the question, understand what is given in the question. So in that way, you have to go into the right place. So now I have finalized that the point is located in the first quadrant. Okay, first quadrant. This is the first thing in the question of solving projection of points. First, you have to identify in which quadrant the point is existing. Right, in the first quadrant. And then, where in the first quadrant? 25 mm above the horizontal plane. This is actually horizontal plane. 25 mm above the horizontal plane. So my method of dimensioning and mentioning the dimensions are pity in this board environment. Okay, you should not consider these things. You have to follow the standards for dimensioning in your paper perfectly. Okay. So above the horizontal plane 25 mm and in front of the vertical plane 35 mm. So in front of the vertical plane 35 mm. So where I am having my point? Exactly here. Exactly here. This is nothing but my point. The point name is A. The point name is A. The point is located in the first quadrant, and based on the given data, it is 25 mm above the horizontal plane and 35 mm in front of the vertical plane. If you see this environment, this horizontal plane and vertical plane environment as a 2D environment, see, like that. So here also it is VP, that is HP, first quadrant, second quadrant, third quadrant and fourth quadrant. Now the point is in the first quadrant and 25 mm, it is 25 mm above the horizontal plane and 35 mm in front of the vertical plane, just like your x-axis, y-axis graph. Okay, and here my point is locked as point A. As point A. Okay, now I got the point. How to project this point? This is the actual activity here. We located everything correctly based on the question statement. Then our duty is starting to, that is, we are going to project the point. So how to project it? Projection is nothing but obtaining the front and top views of the point. Front view should be obtained in the vertical plane and top view should be obtained in the horizontal plane. And let's see how I am obtaining the front view of the point. See students, this everything should be done in your imagination only, not in the paper. This everything should be done in your imagination, not in the paper. See how I am getting the front view. In order to get the front view of the object, I have to see the object from the front. So my visual rays should be perpendicular to the vertical plane. So I have to see from this side. And the view of the object will be deposited in the vertical plane here, just like the shadow. Okay, just like the shadow. But there is a lot of difference between a shadow and a view. Shadow is the thing which is a black shade, but a view is the thing which is the actual appearance of the object deposited on a flat screen. Here, the object's appearance from the front vision is obtained as a front view in the vertical plane screen, and this dot again mentioned as A dash, small letter A dash. The name of the actual object should be mentioned with the help of the uppercase letter, but we are not going to draw these things in the paper, just for our imagination purpose. And the exact front view of the object which is obtained in the vertical plane screen is mentioned as small letter A dash, right? And I am going to produce the top view of the object. For that I needed to see the object from the top. See the object from the top. If I am seeing the object from the top, the top view of the object will be deposited in the horizontal plane. In the horizontal plane, like that. So this dot, that is, this also a point. That point is nothing but the top view of the point capital A, and this top view can be mentioned with the alphabet small letter A. Small letter A. And this dot and that dot are nothing but the top view and the front view of the point A. So this is front view and that is top view. This top view and the front view, that is A dash and A, only needed to be drawn in the paper. We need not to draw these all environment things. Okay, our paper is blank. See, these things are in our imagination and this is nothing but our paper. Okay, so still our paper is empty, only it is existing with the question. What to draw first? We are in the orthographic projection chapter. So in the orthographic projection chapter, how to start the answer, where to start the answer, by which thing we need to start the answer. See, let me to introduce one more parameter here beyond the horizontal plane and vertical plane. This vertical plane and horizontal plane are intersecting with each other, that you already know. See, this is the where the horizontal plane and vertical plane are intersecting with each other. If you made two planes intersect to each other, you will get a line in the intersection zone. You will get a line. So that line here is termed as the reference line. Reference line. And the reference line is mentioned with the alphabets X and Y. This is nothing but X and Y. This X and Y is nothing but the reference line. And why we are considering this line is in order to locate the front and top view in our paper, we need to consider the distance of the points with respect to horizontal plane and vertical plane. But in our paper, it is not possible to draw the horizontal plane and vertical plane. So instead of drawing the horizontal plane and vertical plane, on behalf of the horizontal plane and vertical plane, we are representing the reference line. So this is nothing but the purpose of the reference line. The reference line is the representative for the principal planes. Principal planes, that is the horizontal plane and vertical plane. So the reference plane is then representative for the principal planes, which is to be drawn in the paper, and based on the distance of the object with respect to horizontal plane and vertical plane, we need to locate the front and top view with respect to the reference line. Okay, so here we are having vertical plane, horizontal plane, object. There we are going to have front view, top view, reference line. Okay, this is nothing but in this way we are connecting our virtual world and real world. So first what you need to do in your answer sheet is drawing of reference line. See here. This is nothing but x, y, the reference line, the so-called reference line. So just based on that reference line only, we are going to look at our front view, top view. Here, what is actually front view, top view? Both are just like points only. So since we are processing with the unit projection of points, the shape of the front and top views are same, simply point. But if you processing with the projection of straight lines or planes or solids, the front view and the top views are not same. Based on the location and standing condition of the object, the shape of the front and top views may be changed. But here, in projection of points, the shape of front and top views are same, simply point. And now our duty is to mark this A dash and A in the paper. In the paper, with respect to the XY line. You have to collect the data of these points, with respect to the XY line in this environment and repeat the same here. First, let me to draw the front view. A dash I am going to draw. A dash is here. Okay, A dash is here. Your XY line is there. Your XY line is there. Now, just find what is the relation between A dash and the XY line. Based on that only, here we can draw the A dash. A dash is located above the XY line, right? Above the XY line. Okay. How much above? So what I am asking is, the A dash is how much above the XY line. Here we are not able to use the data related to HP and VP. Here we can use only the data related to XY line. So whatever the data you want to draw, you have to collect it from this environment with respect to XY line. So in that way, this is XY line and that is A dash. So what is the location of A dash with respect to XY? First data above or below. Next data how much above or how much below. It is above XY. How much above XY? What is that distance? Any lead? What is that distance? Very good. 25 mm. See, the same distance is followed here also. The point is located, the point A, capital A is located 25 mm above HP. So that's why we are getting A dash in the VP screen 25 mm above HP. XY is nothing but in the range of the HP only. In the range of HP only. So automatically the distance between A dash and XY is again 25 mm only. Right. A dash is located 25 mm above XY. Simply collect this data and use it here. From XY line, above XY line 25 mm, we are going to have the front view of the point A dash. So dimension line, leader line, then I have to mark the object. Maybe approximately 10 mm apart from the dimension line, I can mark your front view A dash. Front view A dash. See, I just repeated this thing here. Instead of producing all HP, VP there, simply I drawn the XY line and marked the front view of the object with respect to the distance of the object with the XY line. I just marked the A dash. So immediately after marking a point in engineering graphics, immediately after marking the point, you have to draw the projector line of the point, because whatever the object you are drawing here is going to have a pair. It's going to have a pair. If you draw front view, definitely you are going to draw the top view. If you draw the top view first, definitely in future you are going to draw the front view. And in the all front and top views of a particular object are connected with the projector line. Without a projector line, there is no connection between the front view and the top view. So definitely you have to draw the projector line. So how to draw the projector line? Simply draw a line perpendicular to the XY line from the view of the object. See, I just drawn the front view A dash as a point. From this point, I have to draw a line which is perpendicular to the xy line towards the top view area, and there is no specific length you have to maintain for drawing the projector line. Okay, just above the line, above the object left some distance, and below the object towards the top view area give some enough length of line. There is no restriction. The projector line should be the length of 70 mm, 60 mm. There is no restriction. Just flow it with some distance. Right, I have done. And the next step after it is you need to draw the top view of the object. Okay, top view of the object. What is actually top view? Here it is. The A. We just drawn the A dash, which is front view, and A is nothing but our top view. We already drawn the front view. Our duty is now to draw the top view. And the top view A. Okay, XY line is here. In order to draw the front view, what we did already is we just found the relation between the front view and the XY line. So front view is here, XY is there. The front view is above the XY line 25 mm. We followed it here to draw the front view. The same way, you have to find the relation between the top view and the XY line. Top view A is here, just dropped in the HP, in the horizontal plane. The A is here, and a XY line is there. The XY line and A relation is the A, that is your top view, is in front of the XY line, right or not? It is in front of the XY line. But in the paper, it is the 2D environment. We can say only above XY or below XY. These are two choices are there. In front of XY, what is here? We are only here. In front of XY, namma da irukom, vera yarum illa. So in the paper, we can say only above XY or below XY. But here the choice is came as in front of XY. It's not, which is not possible in the 2D paper. So what we are doing is, this is not the time being job, it is a permanent job in the orthographic projection concept. You have to rotate this horizontal plane in imagination. Okay, you have to rotate this horizontal plane in clockwise direction about 90 degree. Remember these things. You have to rotate this horizontal plane in clockwise direction about 90 degree. If I rotate like that, what will happen? Automatically the point A will come here. The point A, if I rotate this plane alone, not the vertical plane, you have to rotate the horizontal plane only, along with the top view. Okay, along with the top view, I am rotating it. If I rotate like that, automatically the top view A will come along with the HP screen and located there. Now this is nothing but the A. Now you can find the relation between the XY line and A. See, it is XY line, it is A, the top view. A is above XY or below XY?
Below 35.
Below XY, very good. Below XY 35, very good, very good. It is below XY first, and how much below? 35 mm. Because see, this 35 is maintained here, and that 35 will be maintained there also. So this is 35. Now the top view A is located below XY 35 mm. Just follow this here in order to draw the top view of the object. So 35 mm below XY. This is the range. 35 mm. And where? Where to mark A? Any lead? Where to mark A? See, this is A dash and this is A. If you see one thing, A will falls in the line of A dash. That's why this line is called as projector line. Here we already drawn the projector line from A dash, which will help you to locate the top view in the future. Now we identified the top view of the point is below xy 35 mm. So below xy 35 mm in the projector of A dash, we can mark the A. A is nothing but the top view of the point capital A. Now it's over. That's it. We just drawn the front view and top view of the object with respect to the given question. This is nothing but a projection of a point. Now we worked with the first quadrant. So the answer is like that. Then you may have asked a question. Always the front view is above xy and the top view is below xy. It's based upon the quadrant. You will realize that when we are working with the other quadrants in the further times. Okay. For this question, this is the answer. And in this answer, I want to add a few things. The point A dash and A, not the alphabets. The point, this point and that point only needed to be drawn with the help of the HB pencil. All other things in this answer you need to draw with the help of the 2H pencil. That is, if you just look at the answer, the point A dash and A should be visible as dark. All rest of the things are just construction works. This point and that point are nothing but the answers. Rest of the works are construction works. They need not to be dark. They should be very, very light. Okay. This is what the way of projecting a point when it is located in the first quadrant. Okay. The next question here is again the point. Now maybe we change the name as B. Is 30 mm above HP and 20 mm behind VP. And you have to draw its projections. One more point. Point B, capital B, located 30 mm above HP and 20 mm behind VP. 20 mm behind VP. Let me to draw the environment. Right. Your horizontal plane, that's your vertical plane, and here we are having our XY line, the reference line. Area okay. It is first quadrant, second quadrant, third quadrant, and fourth quadrant. There it is first quadrant, second quadrant, third, and fourth. First, log the location of the point, where it is located, whether in first, second, third, or fourth quadrant. Point B is 30 mm above HP, 20 mm in front, behind VP. So which quadrant first?
Again.
Above HP, behind VP. Above HP, behind VP. Above HP, yeah, second quadrant. If it is above HP, automatically third and fourth quadrant choices will be vanished. In addition to above HP, again we are saying behind VP. Above HP, behind VP, then automatically first quadrant option will be vanished out. So the final option is second quadrant. The point is now located in the second quadrant. Okay. How much above HP? 30 mm above HP. In that range. 30 mm above HP. And 20 mm behind VP. VP 20 mm behind. So if you lock it, this will be locked here. This is nothing but our point B. Our point B. Now you need to obtain the front and top views of the point B. In this environment, obtaining the front and top views is very easy. Simply, you are looking the object from here. Your visual rays are perpendicular to the vertical plane and the object's shadow will fall over the vertical plane. ஐயோ இங்கிட்டு இருந்து லைட் அடிச்சா ஆப்ஜெக்டோட ஷேடோ அங்கிட்டு தானே போகும். So this is actually our real world logic. But in the case of the virtual world logic, wherever you are blowing the light, the shadow will deposited only in the screen. Whether the object is located in front of the screen or behind the screen, the view is obtained only in the screen. So the front view will be deposited in the vertical plane here. And this is nothing but our B dash, small letter B dash. And we are seeing the object from the top in order to get the top view in horizontal plane. And automatically the top view will be obtained here. This is nothing but the top view of the object B, which is obtained in the horizontal plane. Horizontal plane. Right. We got the B dash and B. Let's go for preparing our work. First, draw the XY line in the paper. XY. Starting from the front view is fair here. Okay. The front view is B dash. Front view is B dash. Now, find the relation between the point B dash and the XY line. Relation is nothing but above or below. If above, how much above? If below, how much below? See, it is our XY line. It is our XY line. B dash is here. It is B dash. B dash is above XY or below XY? Very good. Above XY. Above XY. How much above XY?
30 mm.
Very good. 30 mm. The 30 mm will be maintained here also. So 30 mm above XY, we need to locate the point B dash. $30 above XY. Randomly mark the point B dash. Okay, there is no constraint when you initially mark a point. Approximately maintain a gap of 10 to 15 mm away from the dimension line. So here I am marking B dash, the front view of the object. Immediately after marking the front view, what you need to do is you have to draw the projector line towards the top view area. With the 2H pencil only, you have to draw the projector line. I just draw. Now the next duty is to draw the top view. See here, the top view is that. In the previous question, the object is located in the first quadrant. So we obtain the front view here and the top view there. The front view can be easily drawn with a above XY relation. But the top view is not at all easy in that condition because it lies in front of XY. So what you did is, we rotated the horizontal plane in clockwise direction about 90 degree and bring the point. In order to bring the point top view here. Then we can decide the point is located below xy, that much distance. The same way here also we are going to do. Now the point is located in the second quadrant. We got the front view here and the top view there. Now the top view is behind the xy line. There is no way of doing anything behind xy in the paper. We can do only above xy or below xy. So what we are doing here is the same task what we did in the last problem. We need to rotate the horizontal plane in clockwise direction about 90 degree. So if you rotate the horizontal plane in clockwise direction about 90 degree, what will happen is the point will be located here. Automatically the point will be located here in the VP screen with that distance. So any lead about how much above the top view will come now? If I rotate the horizontal plane in clockwise direction along with this top view, I am rotating it. So what will happen is the top view is now here. If I rotate the horizontal plane, the top view will come to this position, above xy position. Okay, above xy position. How much above xy position in this problem?
20 mm.
Very good, 20 mm. Why 20 mm? Because the point top view is located behind VP 20 mm already from the beginning, because the point B is 20 mm behind VP. So automatically the top view is obtained behind VP 20 mm. If you rotate it with respect to the origin with the same radius, again that same 20 mm distance will be maintained between the origin and the top view. This distance will be maintained here also. So the distance of the point with respect to the xy line now is 20 mm, and the location of the point with respect to xy now is above xy. So above xy we needed to locate the point at a 20 mm height. So it's not like the previous question. In the previous question we obtained the front view above xy and the top view below xy. But now we obtain both front and top views above xy. It is not wrong. It is not wrong. We just followed the procedure to draw the front and top views in the paper. It is the procedure. Okay, there is no strict constraint for always the front view should be above xy and the top view should be below xy. Based on the location of the point, that is where the point is located, whether in first, second or third or fourth quadrant, the location of the front and top view with respect to xy will be changed. Okay, keep this in mind. So now if you are supposed to draw the top view of the object, you have to measure the distance 20 mm above xy. Above xy. Meanwhile, in the projector of B dash, you can mark the point B. Point B is nothing but the top view of the object. Here. In that way, we can draw the front and top views of the object if it is located in the second quadrant. In any question, first you have to identify the quadrant. Thereafter, you can process with the things by the usual procedure. Okay.